right, today we're going to learn about section 1.4, and you're going to be able to identify integers and evaluate absolute values.
Yay!
Some vocab that you need to know that are aligned with this unit are opposites, integers, and absolute value. Opposites are the opposite sign. Okay, opposites are opposite signs. I mean, it's pretty common sense there. If I said -5 and I asked you what was the opposite, what would you say? 5. Right? If I said -13, what's the opposite?
13.
If I said 1.35, what's the opposite?
-1.35.
We got it. Okay? Integers. Technical name for integers is whole numbers and their opposite. Whole numbers are 0, 1, 2, 3, 4, like counting numbers, and then their opposites. So, you can write that down. Whole numbers. Notice how I abbreviated numbers. I use the hashtag symbol. Whole numbers and their opposites. Now, whole numbers, let me denote it in blue, are 0, 1, 2, 3, 4, going all the way to this lovely sign is the infinity sign. So whole numbers go 0 to infinity, no decimal, no fraction. Well, then their opposites, 0 doesn't have an opposite. Well, the opposite of 1 would be -1, opposite of 2 would be -2, opposite of 3 would be -3. Going all the way to the opposite of infinity would be negative infinity. Absolute value represents distance from 0 on a number line. Distance from 0 on a number line. And it's denoted, it's expressed with bars. Some kids think it's a number 11, but it actually represents an absolute value sign. One of the applications we need to do with integers is compare them. When we talk about comparing, we're talking, are you bigger than or equal, are you less than or equal, or are you equal? That's what we do. And what you are looking for, you look to see which one would be furthest to the left on the number line. That's the smallest. That implies it is the smallest number. So if the bigger the negative, the smaller it is what it turns out to be. So -4.4 and -0.5. I'm asking myself, and some students like to see a visual. If this was 0, 1, 2, 3, 4, the -0.5 would be right here, and -4.4 would be about right here. So it looks like -4.4 is furthest to the left, so it is smaller. The next one, it's kind of easier. I have a point here, by the way, and I shouldn't. This should be -4.4. 4.3 is clearly bigger than -1.1. That's easier. The trickier is when you have two negatives. Students mess it up quite frequently. -0.5 and -1/2, what do you think?
Equal.
Equals, right? Equals. All right, next page. We are going to list the following integers in increasing order. So you are asking yourself which number is lying the furthest to the left on the number line. Draw a number line if it's helpful for you. I'm going to give you about 1 minute to do it. Okay, looking at these numbers, I'm asking myself which one lies furthest to the left on a number line. I could easily just plot them quick to make my life easier. This would be 0, 1, 2, 3, 4, 5, 6, 7, negative 8. 1, 2, 3, 4, 5, 6, 7, positive 8. And just start plotting. 8.01, that's a positive 8.01. I'm about right here. Negative 6.99, I'm almost to negative 7. So 1, 2, 3, 4, 5, 6, 7. I'd be about right here. Negative 5.02, I'd be a little bigger than negative 5. Negative 7.01 would be right here. Negative 5.2 would be a little bigger than what I have there. Negative 5.2, and this was negative 5.02. 8.001 is really close to 8, so that would be 8.001 and 7. And then I can label them like that. You do not have to, but if it helps you visualize, you can do it that way. So in increasing order, it would be negative 7.01, negative 6.99, negative 5.2, negative 5.02, 7, 8.001, 8.01. Moving to a nice brain break part. We need to state the opposite. Remember, opposite means opposite side. So what's the opposite of 5.4?
Negative 5.4.
Thank you, Alex. Negative 5.4. What's the opposite of 1/2?
Negative 1/2.
Negative 1/2. What's the opposite of 3.201?
Negative 3.201.
What's the opposite of negative 7.404?
Positive
7.404.
Man, we are like a choir.
404.
What's the opposite of negative 9/3?
Negative.
Or positive 3, it's in simplified terms. Yes, 3 would definitely be it. Moving on. Absolute values. Absolute values are a huge 7th grade standard. Remember, we represent absolute values with 2 bars, straight bars. Absolute value represents distance from 0 on a number line. So distance from 0 on a number line. Absolute value represents the distance from 0 on a number line. They will never be negative when evaluated, ever. Whether you are positive or negative, you are still a distance from 0. Just because you're negative doesn't mean you're a negative distance. You're still a distance. And they act as a grouping symbol when there are operations inside. That means you do them first. So they act like a grouping symbol when there are operations inside it. So I have always asked myself this question every time I evaluate or figure out absolute values. Always. And I am old and I've been doing it a long time. I always ask myself, how far away from 0 is the number? It's always what I ask myself. How far away from 0 is that number? That's the only question that goes through my mind, and it helps me figure it all out. So, for example, you read this one as the absolute value of 5. How far away is 5 from 0? 5. Done. I evaluated it. The absolute value of negative 13. How far away is negative 13 from 0?
13.
I'm 13 away from 0. Negative the absolute value of 23. How far away is 23 from 0? 23, bring down the negatives. So final answer is negative 23. negative the absolute value of negative 45. How far away is negative 45 from 0? 45. Bring down the negative. Negative 45. Now we start having to do multiple operations. If you look at this next example, we're having to evaluate an absolute value and then add to it. So same technique that you just mastered. How far away is negative 15 from 0? 15. Bring down the negative and then add 10.
Negative 5.
Negative 15 plus 10 is negative 5. Moving on, again, absolute value is a grouping symbol. I need to figure it out first. You always figure out absolute value first. This turns into, this one here, turns into the absolute value of 3 plus 4 is 7, plus 3 times 5. I'm not done figuring out the absolute value yet. How far away is 7 from 0? 7 plus 3 times 5. Order of ops tells me do this multiplication first. 7 plus 15, 22 is the final answer. Okay, here's some more evaluating examples. So always, absolute value is a grouping symbol. I take care of that first. This equation here turns into 5 plus the absolute value of 5. Me simplifying inside there. I'm not done. I still have to evaluate the absolute value. I ask myself, how far away from 0 is 5? That's 5, final answer of 10. Okay, next example. The absolute value of 2 is what? 2. I ask myself, how far away is 2 from 0? Bring the negative down. So if the negative is outside, you just bring it down. It will always be negative then. Okay? The absolute value of 4 plus 5 is the absolute value of 9. How far away is 9 from 0?
9.
9. 2 times the absolute value of negative 5. How far away is negative 5 from 0?
5.
So 2 times 5, 10. Now notice my difference there. I have my absolute value symbols and then my parentheses, because that means I evaluated it and I know that I need to multiply them. Okay? Next page. Okay, the next concept with absolute value is comparing. What we want to do when we compare is first evaluate each of the absolute values. So evaluate both the absolute values, each of the absolute values. My grammar's horrible there. And then I see which one is furthest from 0. Or to the left. / to left. I'm going to go quickly through here. Evaluating both absolute values. Negative 3 is 3 away from 0. 3 is 3 away from 0. So they are equal. Evaluating, remember, absolute value is a grouping sign. 7 plus 5 is 12. This is the absolute value of 12. And this is the absolute value of 9. 12 is 12 away from 0. 9 is 9 away from 0. 12 is bigger. Negative 7 and 9. Negative 7 is 7 away from 0. 9 is 9 away from 0. 9 is bigger. Negative 0.001 is 0.001 away from 0. Negative 0.01 is 0.01 from 0. Compare place values. 0 is less than 1. The final concept we're going to do is evaluate for absolute values. Evaluate just means that you are plugging in and simplifying. So I'm going to evaluate for x is 2. Turns into the absolute value of 2 plus 1. The absolute value of 3. How far is 3 from 0? 3. Put 2 there. Negative the absolute value of 2. 2 is 2 away from 0. Bring down the negative. Put 2 here. 3 times the absolute value of 2 plus 3, 3 times the absolute value of 5,